Hello everyone. In the previous video, we had calculated derivative of our cost function with respect to each of the possible weight and biases. And we had done all these in a very simple neural network architecture in which each of the layer of our neural network has only single neuron. Now, in this video, we will increase the complexity. As we know, in the real world scenario, our neural network layer of our neural network has multiple neurons, and in that case these calculation of derivatives are not as simple. Before proceeding to calculate these derivatives, let me first describe you the neural network architecture that we will be dealing with in this video. So as you can see, our network has an input layer and our network has two dense layers. This is layer 1, this is layer 2, and each of these dense layer has two neurons. Okay, now you can see that in the third layer, we have two units, E13 and E23. And with the help of these two units, we will calculate the error made in the prediction. And in this case, we are using mean square error. Let me elaborate you this in more detail. Let us assume that from this neural network, we are trying to predict the height and weight of a person. So at this point, it must be clear for you that A12 and A22 are the prediction made by our neural network. So we can consider A12 as the predicted height of the person and A22 is the predicted weight of the person. And let us assume that Y1 and Y2 are the true height and weight of the person. So the mean square error in the height of the person, which is E13, will be equal to Y1 minus A2 to the whole square, and mean square error in the weight of the person will be square of y2 minus a2 whole square. Now the cost function will be the sum of these two errors. So I have written E equal to E13 plus E23, and from this equation you can see that derivative of cost with respect to E13 is equal to 1, and similarly derivative of cost with respect to E23 will also be equal to 1. Okay, now let's try to calculate the derivative of our cost function with respect to A12 and A22. So here I have written del E by del A12 like this, and as we have calculated before, del E by del A13 is 1. So we are left with this term only. So we can say derivative of our cost function with respect to A12 is equal to derivative of E13 with respect to A12. Similarly, we can calculate for derivative of our cost function with respect to A22, and we will again get derivative of our cost function with respect to A22 is equal to derivative of E23 with respect to A22. Now I am going to play a video from a different source, and in this video you will get a visual intuition of how we calculate derivative in case of multiple neuron in single layer. Also, I will warn you that in this video you are going to see very complex equations. So watch carefully, and I will suggest you to note these equations on your own notebook. Otherwise it will be very difficult for you to follow along. So do this and also try to relate to the concepts that we have covered so far. See you in the next section of the video. Okay, welcome back. Hope you have watched the video very carefully till now. Now, what I'm going to do in the upcoming videos is that I'm going to make several variations on the neural network architecture, and we will try to write derivative equations on those architectures so that we can have better practice of writing these derivative equations. So let me show you what architecture that we will be dealing in the upcoming videos. So this is the first example. Here you can see that I have inserted one more layer in our architecture. So we will see while writing derivatives, you will see that those derivative equations will get more longer, because while going through these paths, our derivative, for our derivative to reach these weights, it has to pass through very long path. And and in the next example, you can see that we have two layers, and in the first layer I have inserted 3 neurons. So we will see how we will write derivative equations in this neural network architecture. So see you in the next video. Bye bye.